Boom. Very well. So, good afternoon. As I was saying earlier, this competency really is about doing some subtle variation on the attack that we've seen in the past, but a lot of it is very similar to what we've seen in the past. Again, we are attacking from Kali. Obviously, it's not Kioptrix 3, it's Kioptrix 4. That graphic is incorrect. But at the end of the day, we're scanning, we're looking for information. The one variation on this is that we're looking for processes that might be running as root. Once we create a shell and we have logged into the K4 server, we are looking for any processes that we could take advantage of that might be running as root. And when we find one, we see if we can't necessarily do some kind of a command and shell out. And that's what this one is all about. It is also in the Kioptrix series, so it takes a look at, the tendency for users to reuse their passwords. So that's really what this one is all about. Okay? I am going to start with showing you the process of how we do this, okay? Because I do this activity several times, no it's not, good Lord, that was horrifying. Okay. Because I do this activity several times, what I do is I have to make copies of the downloaded VMDK file. And that's what you're seeing right now. It's because I had a class just before this, I didn't have a chance to properly set this up. I apologize. But at the end of the day, I just realized that my out of office is still on my... I apologize for that. That shouldn't be there. I'll fix that later. Anyway. Because I have to do this several times, I also delete my VM. And this is something you really need to pay attention to. In the past, when we delete these VMs that we have imported through OVA or we have installed from ISO files, those original OVA files or ISO files are still in place, allowing us to use them again. When we download a VMDK file, and we attach it to a virtual machine. When we delete that virtual machine and we tell it to delete all the files, the VMDK file gets deleted as well. So it is beneficial, if you are working with VMDK files in your future, to make copies of them. Copy, paste, so that you don't lose that downloaded VMDK file. A lot of the activities that we see in the vulnhub, vulnhub.com website allow us to download VMDK files. And I believe it is basically in this context of, you've stolen something from an ESXi environment, a VMware server environment, so let's just take that and try and attack it. Okay? At the end of the day, however, you have something like this. The Kioptrix 4 VMware VMDK file. And we cannot import that. There is no file import option that allows us to import a VMDK file because it's not an export of a VM file. What we need to do is to create a new virtual machine. And I'm going to call this virtual machine Kioptrix 4. It is not a Windows, it is actually an Ubuntu-based system. So as soon as I start typing UBU, it auto-completes for me to a 64-bit Ubuntu. Now, it doesn't really matter if it's a 32-bit or 64-bit VM. A 64-bit setting in the virtual machine hardware settings will accommodate either a 32-bit or a 64-bit virtual machine. So this works for me. I'm happy with that. It has the appropriate settings, and we can click on Next. As it is a headless server, a terminal server, one gig of RAM should be sufficient. Click on Next, and it is on this screen here where we need to ensure that we say do not add a virtual hard drive. Okay, we have the virtual hard drive right here. It is our K4 VMDK file. We are going to attach it to this virtual machine after we have set it up. Okay, so the important thing is we're not going to use the existing virtual disk option as well. I want to show you how to do this outside. Okay, because sometimes you need to add disks for to existing virtual machines for the purposes of performing forensics analysis, which is something I still hope to get to before the end of the semester, although it's starting to look less and less likely. Okay, if you are going to do forensics analysis, you need to add an existing image to your virtual machine. We will probably use the SIFT virtual machine from SANS. So you need to understand how to do this. Let's start with that now. Okay, so we do not add a virtual disk at this time. We create a virtual machine without. And because we are creating a virtual machine without, VirtualBox says, hold on, you might be doing something wrong here. But we know what we're doing. We're going to say, that's okay. Click on Continue. And we now have a virtual machine. If you have not done so, sorry, I have to do one more thing here. If you have not done so, you should also fire up your virtual machine as well. The new Kali that we set up in our last class. I've set it to mutable because I make changes to it during my attack, and I have one more class that I have to do this with, and I don't want any of the work I'm doing in this class to be reflected in that class. So I might as well show you what I've done because a lot of you saw it. Under the Media Manager, which allows us to manage the drives and the CD-ROMs that we attach to our virtual machines, you can go in and take a look at the individual attributes of virtual machine disk files. And you can check out the attributes. And one of the attributes is immutable, which means that after I'm done firing up this virtual machine, I go through my attack, I power it down, it's going to lose all the settings I made to the file system. Okay, it's something I use in my malware analysis course with my students there, but for what we're doing here in this class, it is out of scope. I just happen to do it so I could have this virtual machine here available to me tomorrow for my pen testing class tomorrow. So that's just me explaining what's going on there. Okay, you should of course have your Kali working properly. Okay, let's go back to our K4 server. If you haven't done so, start firing up your newly imported Kali machine, but we're going to take a look at K4, and we are going to look at the settings. As it is an imported system, we should verify a lot of our settings. Our memory is fine, our processors are fine, our display is fine. We're only doing, like I said, a terminal access, so this is more than fine. There is a problem with the storage. We're going to come back to that. Audio is fine. We will definitely come back to network. Serial ports, USB, all of those are fine. We have no errors, so we have nothing to worry about there. What we really need to do is focus on network and storage. Let us start with storage. First off, each of these is a controller, a hard drive controller that allows us to attach hard drives to our virtual machine. Within these controllers, we can add devices to the controller. That's what these little icons here perform. Okay? You can add new controllers, you can remove controllers, and you can attach storage devices like other types of NAS types of things, I believe. What we're really focused on is adding a hard disk to an existing controller. Now we could use IDE, but I believe this is new enough that we would use a SATA controller for our VMDK file right here. So in our settings, for our K4 server, we go to storage, we select our SATA controller, we click on the little add hard disk icon to bring up the Media Manager. If you're using an older version of VirtualBox, it'll actually won't bring up the Media Manager. It'll just say select a hard drive image. It is the same process. It's just a slightly different interface. If you do get this Media Manager interface, what we do is we click on Add and we navigate through our file system. I'm going to go to D. I am going to click on my InfoSec downloads, and I'm going to go specifically to the folder that I downloaded my VMDK file. Okay? If you do not have the Media Manager, you would be taken to something exactly like this by saying select hard disk now. Regardless, you click on open and it is either added it for you or you simply click on choose. I scroll down and I specify choose this VMDK file. And when I do it, this is what we are looking for. On our SATA controller, we have the K4 VMDK file. Okay? I'm assuming everybody is okay. If you have any problems, either speak with chat or jump in by unmuting your mic. Otherwise, I'm going to move forward. Okay? So that was our hard drive. The other thing we want to do is enable. Now, again, with my technically inaccurate diagram, we have Kali set up and it uses two adapters. As always with this is our target machine. We only need to access it on our host-only network, and that's what we're going to configure. Because we set it up, it defaults to NAT. So we have to say host-only adapter. You should only have one host-only network. And we need to set our promiscuous mode to allow all, in case we want to attack it from our Windows host environment as well. Okay? We do not need adapter 2, 3, or 4. We need one adapter, and it should be on our host-only network with promiscuous mode set to allow all. Once we have that, we can click on OK, and we can start our virtual machine. It should start up without problems. Are there any questions? Oh yes, because it hasn't started in a long time, it forces a check, an integrity check of the data partition, the main root file system. So it is forcing, and that's what we were seeing with that ASCII-based progress bar, as it's forcing a drive check. And that's just because, again, it's a VMDK file that represents the hard drive, and as far as it's concerned, it's been over a year since it's been checked. It's due for a check. So that's all that was. If there are no questions, we now have our virtual environment up and running, and we can start our attack. Again, I normally give you ISOs, but I wanted you to see the process of adding non-ISO or non-OVA files to our environment. Not ISOs, but OVAs. I want you to actually see the process of adding an existing hard drive to a virtual machine. Okay? So here we are in Kali. Because this is the downloaded one, our username is root, and in case you've forgotten, our password is tour. Okay, and I have chatted those out for you as well. Now that you have it, we really have nothing here other than Ligoat security server, which is funny because it is quite vulnerable. Nevertheless, let us take a look at trying to attack it. As always, we need to verify our IP information. You should have two adapters, ETH0 and ETH1. You should have used ETH0 to set up all the necessary tools for today's activity, and your ETH1 should be on the host-only network. There is a lot going on in this class, so what I am doing is I am going to start capturing this information in our little text editor. Okay, first off, the IP address of my Kali. All right. Knowing that, I can scan my network. Again, double click, paste, back, 0/24 to scan the network for potentially vulnerable machines. It should happen fairly quickly. As always, we really need to understand our environment. This is our gateway address for our host-only network. This is the DHCP server for our host-only network. This is the last one in our list, and it happens to match the IP address of Kali. We can ignore this, which leaves 180 as the unknown IP address. We can assume, therefore, that this IP address is our K4 server and will be the one that we attack. Okay. First things first, we do a detailed scan. We can scan, correction, that one. Double click and middle button or mouse button to paste. Okay. And it gives us some great information. We can, of course, always do the -A as well, uppercase A. And we can, of course, do the full port scan. Like that. But I don't think we're going to get extra information. If this was a real attack you were performing as part of a pen test or red team attack, you would, of course, do as much scanning information as possible. It's all about looking for clues. Okay. Our initial scan, however, has given us some very good clues to work with. SSH server is running, Apache is running, and Samba seems to be running as well. Okay. Let us initially take a look at Samba, only because we know, as seasoned pen testers, that Samba is notorious for having vulnerabilities. Even the most recent one, I can't remember what the vulnerability is called, but even the most recent version of Samba has some vulnerabilities that a proof of concept has been recently released. I think it was in the last week. I shouldn't do this in the middle of a lecture, but this is the kind of teacher you have, so, you know, sucks to be you. Where was it? I can't find it. SMB Ghost. That's what it was. So if you're curious about even the most recent issues with the SMB client, there is an SMB Ghost vulnerability, CVE 2020, so the almost 800th vulnerability of this year. This is a relatively new version of Samba, and it impacts Windows 10. Okay? But they've announced it, they have patched it, but somebody's already done a proof of concept if you wish to play with it. It is out of scope for this class, but as I said, by way of proof, there are a lot of issues around the SMB protocol, which is why we are always trying to take a look to see if there's something we can't do to take advantage of it. Oh, and I know you're sending me emails. We're going to have to pick this up after class, so I hope that's okay. So, the first thing we want to do, and the reason why we did our entire configuration in yesterday's class, is so that we can take a look at this Samba information. The HotWax toolkit added a lot of tools to our instance of Kali. The one we are most interested in is a functioning version of enum for Linux. Again, we want to target on that K4 IP address. Okay? And this is what, and I know we've done this before, but it's been problematic for a while, but this is what the correct run of enum for Linux should look like. It goes through and it takes a look at a lot of information. And it just keeps trying things over and over and over again. And it gives us screen after screen after screen of results. You, of course, want to look at excruciating detail at each of these to see if there's something you can take a look at. This, augmented with a lot of the tools built into the MSF console, might realize some vulnerabilities. But this is the big win by running enum for Linux at this point. The fact that we find 3 real Unix users and their user IDs. This is the big win. And we've talked about this before, okay? We have talked about how username and passwords, it's the best system we have, but it has some inherent weaknesses. One of them is that once you have a username or a user ID, you've got half the formula for gaining access to a system. It is, of course, the easy half. It is nevertheless half of it. In the past, where we have used things such as Medusa to attack our virtual machines, what we needed to initially get was a username. Once we had that, we could start cracking services such as SSH to try and figure out the password. So, and you can do that with this as well, by the way. We're not going to because it's really not effective. And when you see the passwords, you'll understand why. But at this point, you could start doing either a dictionary or a brute force attack based on those credentials. Keeping in mind that, sometimes you need to have a real slow attack because a properly configured SSH server will block a certain number of attacks over a certain amount of time. So I would do one attack every 5 minutes, 2 attacks every 15 minutes, something like that, just to make sure that I don't create a lockout scenario for the account I'm trying to attack. Okay? Nevertheless, we have some user information. Let's open up a new tab and take a look at the web information as well. Okay? We're going to do derb http:// and our IP address of 180. It should still be, nope, that was a mistake. I had the wrong thing in my buffer, but that's fine. Double click and I can do derb http:// and I can paste my IP address and it'll run through, and it doesn't give us much. It does give us something called logout. It does give us something called member. It does give us something called John. That's interesting. Images. It does look like there might be a WebEx, a web application running on this machine. Of course, we never just run one, nicto-h, and again, I'm going to paste, that IP address. Now, some of you are noticing some issues with Nikto. I don't understand what the unusual thing is, but some of you are having to run a slight variation. I don't really understand why, but it doesn't matter. We know what the problem is. We know how to fix it. Instead of just typing in a host, sometimes we need to specify a protocol as well. http://. Okay? If you run Nikto and it says no host scanned, even though you've used the -h switch, add a protocol. Add the HTTP protocol as part of your scan. Okay? I'm going to stop that. And we take a look at the results from Nikto. We don't really get much. Seems like this time we even get a little bit less than what we got with our derb scan. Something going on here, and somebody called John. At this point, of course, we want to fire up our browser and start taking a look at this site. just arranging my desktop. So our site was 180, right click, copy selection, Control L, Control V, and there was something about something called John. Let's take a look at that. John.php. Oh, it's taking us back there. So there is some kind of an application going here. That's great. Everybody can see that nice and clear. So let's try this again. John, and we're going to do our standard SQL injection. There's no easy way to make the font larger. Okay. It's a little easier to read. So we're going to do our standard SQL injection on this login page. Let's just assume, because it is PHP, that it's MySQL. As always, if one doesn't work, you try the other. It might be a more generic. In a perfect world, all web applications would use PostgreSQL and not MySQL. But that's just my personal bias. We will assume, and trust me, rightfully so, that it is going to be the MySQL comment. So that will become our injection, okay? And we will log in. And right away we get, my name is John. Ooh, cool. So we know that username John has a password of my name is John. We also had a Robert. Maybe we can take a look at Robert as well. And again, we're going to use, just because it doesn't echo back what we're texting in, it just gives us those password masks. We'll try that. And wait a minute, it was John, but we typed in Robert. There's something wonky going on with this web application that's just a little weird, and it isn't because we started by going through the John directory that we have indicated here. This indication here where we're talking about John, it doesn't have anything to do with that. There's something very wonky going on about this. If you want to try another user, you're actually better to close the browser down, start the browser up again, and then try again a different user. Okay? So I'm going to go to this, and I could even try Robert. Let's do Robert first. Okay? And see if we can't get a password from Robert. Control C, Control V, log in, and wow, Robert actually has a relatively good password. Good for Robert. Because I don't think that is a hash. I really believe that that is a plain text password stored. The third one we wanted to take a look at, the third user we found when we did our enum for Linux scan was Lone Ferret. We've seen that name before. Let's take a look at Lone Ferret. Okay, again, I'm going to close this down. Again, I'm going to bring up my web browser. Again, I'm going to go to that site and try logging in as Lone Ferret with the password. And when you do that, kind of looks like Lone Ferret logged in. Oops, something went wrong with your member page account. Please contact your local administrator to fix the issue. Thing is that this kind of breaks everything, and this is how I knew that we needed to have different instances of your browser for each one of these attacks. Because once you do Lone Ferret, say, okay, let's go back. Let's try John. And for John, we are going to, again, try that SQL injection. And kind of looks like something may have worked, but something went wrong because it's still trying to remember, I think, lone ferret. Okay, it says John, but it's doing the something went wrong thing, and this worked before and now it's not working. So this is usually my indicator that there's something wonky going on. Let's just do a clean attack for each username that we want to try. Again, just to prove that it does work, we're going to try as John. And I still have the standard SQL injection in my memory, and it does work. Only because I started a new browser. So file that away for future reference. Any questions on that? Now that we have successfully done that, we can now open up a third tab and we can start an SSH session. The SSH is going to be John at our IP address. This is why we have our text editor open. Highlight that, paste, and it will ask us if we want to store this connection information in our local cache. We type in yes, and it's permanently added the IP address, and it wants to know what John's password is. Now I could try typing in my name is John, but you've all seen how bad I am at typing, so I'm going to copy and paste in the clipboard, and it is going to let me log in. Unless anybody is not at this point and is confused, please let me know. Okay? Otherwise, this is pretty straightforward stuff up to this point. We did a basic SQL injection. We had some issues with the browser, but it's a basic SQL injection, a really poorly designed, almost, contrived home page once you're logged in that serves up plain text passwords. Fine, that's fine. We can accept that and move on. And once we do an SSH session, we are able to log in. Please keep in mind that this should be a basic, straightforward SSH session that would allow us to type in, who am I? But it's not. It's a special shell, so we won't screw up. As we have seen repeatedly with the whole Kioptrix line of servers that we've been attacking, they repeatedly use security through obscurity, trying to prevent their users from compromising the system. Rather than having hardened, up-to-date systems that don't have introduced vulnerabilities, they keep pulling these foolish shells and these foolish tricks to keep people from hacking their site, which is, of course, always doomed to failure. All right? It assumes that there aren't smart people like all of us out there who can't take advantage of this. First things first, it's a separate shell. Type in question to see the list of allowed commands. All right? Right away, this offends me because I'm not going to live by their list of 8 allowed commands. One of them, or none of them, is the sudo command. So evidently I can't elevate myself using the sudo command. Interesting. They do allow, however, the echo command, which is interesting. Because, I don't know if you recall this or not, but a while ago, when we were looking at remote shells, I showed you a list of shell commands that you can use to start a better shell when you've got a bad shell. In this, we have a bad shell, so we can use the echo, because it is one of the allowed commands. We can use the echo command to do os.system, and with that, we are going to specify the bin bash command that we want to execute. Highlight that, copy, come on over here and paste what's in the clipboard, and it will give us a better shell. We can see it right away. This looks like our traditional bash shell. And it will allow us to execute more commands than this original limited list of commands. Okay? This shell, this LIGO security shell that they have in place, limits us from doing things. Okay? Because we chose, or because they allowed the echo command, and because we know that we can do system calls like this to give us better shells, we put the two together to allow us to circumvent this security through obscurity technique. Any questions on that? Alrighty. Did somebody's mic just go hot? No? Okay. I thought I heard somebody's mic go hot. All good. Alrighty. So, now I am in. Let's try the sudo command. Oh, sudo is installed. Awesome. So clearly this shell isn't used by everybody. We know what John's password is, and it is my name is John. All right. John is not in the sudoers file. This isn't it will be reported. Sudoer does that every time. Don't worry about it. Again, however, if this was a red team activity and you were trying to attack without letting your presence be known, you may have just made yourself known. So you may want to go through, become root, read the mail, remove this, mark everything unread as root, and then step back. Okay? If you're trying to do a red team attack, cleaning up after something like this, if you really want to, can be problematic. To be honest, sudo command always reports this, and I've never actually seen a report appear, so govern yourself accordingly. The potential is there. The practical application of it, however, is very, very low in my experience. Nevertheless, sudo is installed. There is a sudoers file. Let's take a look at it. Cat etc sudoers. And of course, this will not work because the sudoers file is set up so that people can't see it. Okay? Any questions? So we need to figure out how to act like root at this point. One of the tricks, as I mentioned in the handout, and I just want to make sure I'm not missing anything, I'm right now halfway down page 4 of the handout. When you're trying to escalate yourself to become root, there are a couple of tactics we are going to look at in this course. One of them is finding server processes that are currently running as root that may allow us to do some kind of a shell out or a system command. Looking for root server processes involves the ps command. I hope you have seen this before. When we type in ps, it gives us a list of commands. Okay? I'm going to exit out of my bash that I typed in before. You do not have to type in exit. But whenever I am just in their LIGO shell, if I type in ps, that is one of the commands that are not available. So again, we could not do this until we are in a different shell. And now we can type in the ps command. PS also allows us to do the EAF argument, where we can see everything running, full information, including who the user is that is running this process. We're going to pipe that result to a second command. If we didn't, we just end up with a really long list of commands that we could go through and take a look at, but we really want to focus what we're looking for. We want to pipe that to the grep command, which looks for a string. The grep string we are looking for is root. And that's the command that you have, again, halfway down page 4 of your handout. And this really focuses our information. When we type in this command here, it gives us all the processes that are running as root. And what we would do is we would go through and look at all of these processes and see if there wasn't something we could take advantage of. Okay? Cron sometimes lets us shell out, but not always. Apache's running as root. Well, that's just horrifying. If somebody can create a shell in Apache, they can run their shell as root. This is horrifying. MySQL is running as root. We've seen shells in Apache in the past. There's really not much we can do with that website. Certainly no file upload that would allow us to start a shell. There is no exploit that we have covered that we can take advantage of with that web server, but it's something to keep in mind. And if we were reporting this, if we were doing a pen test, that would be one of the things that I would definitely put in my report. But we are going to focus on MySQL running as root, because with MySQL there is the ability to sometimes do system calls. I believe it was done in the context of triggers in the database that you want to do things like send emails or do system modifications, add partitions or those kinds of things. It's not always installed. It's usually limited to people being root being able to run those things. But if we can do something as root inside of MySQL, it will run in the file system as the Linux root. If we can do something as MySQL root, it will do it as Linux root. Okay? So that's what we're going to focus our attack on. Are there any questions? Alrighty. We know there is a web application here. We know in most cases these websites are in the var www directory. And when I do an ls, we don't really get a config. I mean, I can search for config. I can look for the MySQL_connect. But this is a pretty simple application here. There's a database.sql file. You can take a look at it. Let's take a look at it. Cat database.sql, nothing there. And by the way, because this is an SSH session using bash, the tab does work for us. Okay? This looks like a create thing that really doesn't help us much. Okay? John obviously doesn't have the password 1234 anymore. There is a check login, login success, logout. Well, let's just take a look at these. Let's take a look at the check login.php file. And right away, when we scroll up, we see serious issues. Not only does the database application, not only does the PHP application use the database username root, there is no password associated with that username, which is just unforgivable. This is bad enough. As we've seen in the past, having web applications connect to the database as the database root account, that is egregious enough. To augment that, to not have a password on that account is almost criminal in its nature. It is, of course, done on purpose on this because this is how we are attacking this server, the K4 server right here. Okay, so it's done on purpose. That's fine. If this was in the wild, if this was in the real world, you never want to get somebody fired for making a mistake. But if a person keeps making this mistake, they actually need to talk to HR at some point. This is egregious. We now know that we can start a MySQL session, connect as root, and not be prompted with a password. We can be confident in this because we were able to connect to the database through this application. Let us try. And by the way, I am now at the top of page... Nope, we finished page 5, so we are on to page 6, where I've got the graphic there. We are very close to being done this attack. Okay? So, the command is mysql-u as root. If there was a password, we could say specify the password, but we've seen that there is no password. Okay? And we are in. And we are in, frankly, as user root, which is, of course, horrifying. As I said before, and you can stay in, there is a file in the etc folder called group, which lists all the groups. We know that, and I meant to mention this earlier, and I'm apologizing because I didn't. When you're using sudo sudo tends to use group assignments rather than just individual user assignments. I'm not sure if I taught you guys information systems in semester 1, but as a general rule, when it comes to doing authentication and authorization, you do individual authentication, but once you are authenticated to a system, you tend to do group authorizations. It is a fool's errand to continually give individuals access to resources. It is often much better. I mean, it requires a little bit more work up front, but it is usually, from a systems administration point of view, it is almost always better to give groups access to resources and then subscribe individuals to those groups. A little bit more work up front, it's always paying off in the long run. I'm sure you've seen this with Nola and with Jeff in your networking and server admin courses. Okay? There is an admin group. We know sudo tends to use an admin group like that. So what we want to do is try and add John to that admin group. And we do this, you can see this command in the handout, and I'll try and type it again in our text editor right here. I'm not going to do that. The command looks something like this. Select system sysexec, and with the sysexec function, we do the following Unix command. Usermod add to a group. The group is admin and the user is John. We close off the command, we close off the argument list for the sysexec command, and then look at that, I managed to have the window the right size. And of course, because it is a select statement, we have to have the semicolon at the end. This is again page 6 of your handout, and this is the injection. Because we are able to run our command as root in the database, and because the database software is running as the Unix user root, we can make root level changes to our system by typing in select, and the select statement is the sys_exec, and the argument is the usermod command. We are going to add to the group admin the user John. Closing tick, closing bracket, and semicolon, just like that. And it returns a null. It doesn't return an error or anything like that, but now that we have done our user modification, we can exit out of MySQL. Again, take a look at the group admin. Lone Ferret, who doesn't seem to have, remote access, who probably isn't living at the same restrictions we are, seems to be an administrator. We've added John to the admin group as well, and now I can try the sudo su -command again. Again, because it's been more than 5 minutes or whatever the threshold is, it wants the password again. My name is John. Who am I? And we have elevated our account, or escalated our account to root. Any questions? Does that make sense? By way of review, never run server processes that allow, especially server processes that allow remote connections, as root. All right? The web server process Apache 2 should not be running as root. The database server process MySQL should not be running as root. The reason being is because if someone can compromise those processes and spawn system calls or spawn their own shells, they at that point run as the root user because they are a child of that server process, which is problematic. Okay? If you're going to set up MySQL, go through the documentation, use the MySQL user ID that is recommended, and then run the process as that user ID. If you run it as somebody else, that's the permissions that that process is going to run under. Same with Apache. Back in the day, and I'm guilty of this, back in the day when setting up server processes was challenging and we didn't really understand the consequences of this, It was always easier just to say, screw it. I don't understand all these persnickety little permissions that this thing wants to do. I'm just going to run the installer as root. I'm just going to run the application as root. It works great. What's the next problem I got to put out? We've done it. Hopefully you won't do it in your careers, but those of us who are old enough, we've all done that shortcut. Now we understand the consequence of that behavior. And really, you shouldn't be doing that. Any questions? Does that make sense? No? Okay, I'm going to stop recording our session at this time.